Santarsieri.
Thank you.
You're
Please,
welcome.
you can start.
Okay, hello everyone, and welcome to this talk, SAP Incident Response, real-life examples on how to attack and defend. Before we start with this presentation, let me tell you that here you won't see fairy tales. You won't see a story when the good guy always wins. No, here what I'm going to show you is my real-life experience of doing SAP forensics. What you're going to see is the state of how the market, how the SAP implementations are right now. Okay? So before we start, I always put this disclaimer. No one reads it, but it's important. Basically, it says that I don't try to override any rights that SAP has in their products. So who am I? My name is Jordan Santarsieri. I'm originally, or my background is for penetration tests, vulnerability assessment, audits. I found vulnerabilities in SAP and Oracle software, IBM, etc. Normally, I present this kind of talks on different security conferences. I have presented in Black Hat, OWASP, Hardgate Halted, Echo Party, and now at the Insomni'hack. Thank you for that. And because of my experience, and I started doing this since 2008, I was able to secure or work with more than 1,000 SAP implementations out there. Fortune 500 companies, ONGs, military institutions, etc. Recently, I founded my own shop, it's Vixer, and basically what we do is to provide security for ERP, like eBusiness Suite, Oracle Civil, and SAP itself. And because of that, I was able to gain a lot of my background in vulnerability assessment, penetration testing, trainings we do a lot, especially in Conf, and SAP forensics. That is what you're going to see now. I have divided this talk in, first of all, a brief introduction of SAP. I know that not all of you guys might know what SAP is and how it works. So we're going to have a very, very brief introduction about it. We're going to start for the basic concepts. And then we're going to see three different misconceptions that are three different real-life stories. We have the first misconception, and they're kind of funny. You take away the SAP word, maybe you have heard about these misconceptions before. Misconception number one, we have never had an SAP security incident before. Chapter 3, we will have another misconception. We thought that SAP cyber attacks were actually not real. And the last one, the last of the misconceptions, is the probability of a cyber attack is low. Okay, so let's start. First, we're going to start with this brief, very brief introduction to SAP. So the first thing that you might be wondering is, okay, what actually is SAP? Let me tell you that SAP stands for Systems, Applications, and Products in Data Processing. So no wonder everyone actually calls it just SAP. It's actually a German company. It was founded in 1972 by ex-IBM employees. And let me tell you that these guys are huge. They totally dominate the market. If you take a look at the numbers that they have, SAP has more than 88,000 employees worldwide. That is massive. They have more than 378,000 customers, and they're in more than 180 countries. That is almost every single country that is out there. Almost every single country. And they totally dominate the market. 87% of the Fortune's 2,000 companies use SAP. What does it mean? That SAP is in the biggest and most important companies out there. It's everywhere. So following this really, really brief introduction to SAP, and for you to understand better the attacks that are about to come, I have divided the solutions that we're going to be talking to in enterprise solutions and supporting solutions. The enterprise solutions are the ones that the human beings, that the employees of a company are going to be working with every day. For example, maybe you have it in your company to ask for vacations, you go there. To check for benefits, you might go there. Examples of these enterprise solutions, the main one, the SAP ERP, maybe you hear about it, or enterprise resource planning. If your company only bought one SAP system, they have the ERP. It's the core of the SAP infrastructure. In the ERP, it's very common to find credit cards, HR information, materials, formulas, etc. Then you have other types of solutions that are very common and very popular. SAP BI or Business W for business intelligence, maybe you hear about it. SAP CRM. Every time a customer picks up the phone or consults a web page, that interaction between the customer and the company gets registered on the CRM. Very valuable information. And then the SRM, the Supply Relationship Management. From the other side, you had supporting solutions. The name indicates that this type of solutions will support the enterprise solutions. Normally here, you won't have your daily user logging in. You will have more technical users, more administrators, with the exception of the mobile that is out there. A very big important difference, and we're going to speak about it on the next slide, is that the enterprise solutions, the one that you see at your right, are NetWeaver based. We're going to see what that means very shortly, but remember that most of them are NetWeaver based. And the supporting solutions, more often than not, are not NetWeaver based, with the exception of, for example, GRC. That is where you go on SAP to apply segregation of duties, that I'm pretty sure everyone knows about. So, what is this NetWeaver that I keep mentioning? NetWeaver is the framework where SAP is built in. It's one of the most important technologies on the SAP world. NetWeaver is service-oriented, meaning that it will have different protocols that, by the way, in the SAP world, actually in the ERP world, is very, very common that you have to work with proprietary protocols. Nowadays, the trend is to try to go to more standards, but you will still find tons and tons of proprietary protocols. Think about it. They started in 1972, so they have a lot of legacy stuff still there. So this NetWeaver that we already know that is service-oriented can be divided in two. From one side, you have what we call the ABAP stack. It's the most important one. Why? It's normally used for backend. So it's where the credit cards are going to be. It's where the purchases are going to be processed. And from the other one, you have the Java. It's more common to be used for a front end. Don't get me wrong, you can find both types of SAP systems on the internet, but it's very, very common to find the Java ones. And there is an old concept that is also still relatively common, is the concept of dual stacks, meaning that one SAP system will have both stacks, all the services, all the implementations that correspond to the ABAP system and all the services that correspond to the Java system. The platform of attack is a little bit bigger. So if you take a look at the image that I have here, this again is a very brief introduction of how an SAP system looks like. Every single SAP will have one and only one database. Every SAP system will need an operating system to work. And here, in the middle, almost in the middle, is the SAP NetWeaver, or you might hear it in the documentation as well as the SAP application layer. This NetWeaver framework will regulate how SAP will always operate with the operating system and how the SAP will always connect to the database. Then, what you put on top, the business logic, will determine if you are actually dealing with an ERP system or a CRM system. But if your SAP is NetWeaver based, 75% is exactly the same. And from an attacker's standpoint, that is very useful. Why? Because if you find a vulnerability on an ERP system, chances are that the same vulnerability will work for your CRM system. So be careful with that. Continuing with this brief introduction, we have different concepts in SAP that are very ABAP related. The first one is a transaction. Let me tell you that SAP is not just point and click. Nowadays, they're doing more efforts to go to be more web related, but unfortunately, you will have to remember a transaction code to go from one screen to another. A transaction is no more than a trigger. You enter the code and that will call a program. You can have custom transactions, you can create your own, or you can use the default transactions. Same with the programs. The programs, and this is more ABAP related, are just a procedural ABAP programs. Do not confuse it with the ABAP stack. I know that it's tricky. ABAP is also a proprietary programming language that SAP has. Very similar to QBasic, if you remember QBasic. And again, also you can have your standard programs and your custom programs. This is very common to have custom programs on every single company. And finally, you have the SAP function calls. You can see function calls as remote APIs. You can invoke a function call locally, meaning from your SAP system that you're standing to yourself, or remotely from one SAP system to another, or from a Python script or a Ruby script to the SAP system. That is also very common, especially for interfaces. Most of these remote function calls are authenticated, but there are some that are not. So following the line with this presentation, there is no secret that cyber attacks are getting more and more popular. I think there are both ways. They are being increased in terms of the number, and every day the media loves to showcase those scenarios. What is really interesting, if you compare the security from here to like 20 years ago, is that some directors are being displaced of the company because of a cyber attack. That is very interesting. For example, the Equifax scandal where the CEO was asked to resign, or the Target, they were complete compromise and they literally fired their CISO. So we need to try to ask ourselves, okay, why someone would try to hack my SAP system or my company SAP system? First of all, the business critical information is right there. We mentioned it before. Credit cards, formulas, materials, traffic routes, everything will be on your SAP system. Sensitive information, but most importantly, the organizations highly depend on it. Except if you have an SCADA system in your organization, I guarantee that if you have SAP, that is your biggest and most important system in your organization. Because literally, it's where the money is. It's where you are constantly processing the money, either directly in the SAP or interfacing the SAP and another system. And naturally, that makes these kind of systems ideally for attackers to perform espionage, sabotage, and fraud attacks. So, as I promised, before we jump on the misconceptions, I'm going to show you 3 real-life scenarios, situations that actually happened. But for consideration to the victims of this situation, I'm not going to mention neither the name of the victims, and I will try to avoid also the country of where this happened. So, let's jump right in. Misconception number 1. We have never had an SAP security incident before. I hear this phrase a lot, and not just with SAP. Like, we never have a cybersecurity incident before. Okay, so this is the scenario. Someone hacked a domain admin account. We don't care how. And they use that account to escalate and penetrate pretty much everywhere. You name it, workstations, servers, switches, and of course the boxes where the SAP systems were running. This is crazy, and it was the first time that I saw this. These guys literally deprecated every single piece of technology in the company. VPN terminators, bye. Servers, workstations, everything away. They created what is called this white room. It was crazy that if you wanted to go there, you needed to leave your backpack, your cell phone, if you have a smartwatch, everything that was technology related had to be outside. Only the things that were installed in the white room were allowed to continue. That was very crazy. So the main concern of the victim here was to determine if SAP was especially breached. I mean, they know that the boxes were owned. They were domain admins anyway. But they wanted to know if someone specifically was going to be able to get the credit cards or, very important, personal identifying information, something that you will hear a lot on this presentation. Our focus or the scope that they gave it to us was the ERP system. Why? Because they were processing a lot of payments and all the credit cards of the customers were in that ERP system. If we were able to prove that something bad happened on that system, game over. They need to go public and they need to split give an explanation of the situation. The only caveat here is that the forensics of the database was handled by another team. A very, very well-known forensic companies that they manage these kind of situations. We were only focusing on the SAP side. So, whenever you hear we have never been breached before, we never have an SAP cybersecurity incident before, the first thing that you need to ask yourself is, can we really be sure about that? I mean, in Java, the stack that we mentioned before, some of the security audit logs do come enabled by default, right? But in ABAP, it's not the case. It's not the case at all. So whenever you hear that misconception, you need to ask the customer or the stakeholders on your company, it's like, okay, but do you have the security audit log enabled? It's actually that log enabled if all of our SAP systems, for all the users, for all the important filters that SAP has. I guarantee that when you ask that question, I guarantee, because I have seen on my projects, 90% of the cases, the answer is no. That thing is not enabled. But let's be kind here. Let's pretend that everything is fine, and let's assume that the answer is yes, because they have it. Then, as I mentioned before, SAP, the NetWeaver, is service-oriented, and each one of those services might have its own set of logs. For example, here the gateway is a very common component that attackers choose to attack. That thing doesn't come with the security audit log enabled. The message server, a very important component used to do load balancing, doesn't have the logs enabled by default. So, okay, let's suppose that you have the security audit log enabled, but do you have the other logs enabled? Still, the answer is no, I guarantee. And finally, let's suppose that we are in a magical world where all the logs are enabled. Is someone actually retrieving those logs and paying attention to those logs? Unfortunately, in the state that the market is right now, I'm not just talking about Europe, this is Europe, the American continent, etc., the answer is still no. So, with this information that we saw, we started working. And here is another complexity. The SAP system that we were working with had 4 virtual machines. They have a central instance, and then they had 3 different application servers. When you do a forensic analysis, you need the logs from pretty much everywhere. Everywhere. Why? Because even though some logs are system-wide, some other logs depend on the application server. So 2 application servers might be clean, but on the third one, you found how the attacker was able to get in. Very important. So we start reviewing, they give us the entire virtual machines, it was a lot to process, we mount the disk, and we start seeing, the first thing that you do, you start seeing what logs are actually available. And by the way, I have put it there on the table for you, so you can see, okay, the default location of the logs. We started with the ABAP security audit log. It was not fully configured, but it was partially configured, so enough for us to start working with. The SAP gateway, we didn't have. Doesn't come by default, it was not activated. The SAP message server audit log, no. The logs from the operating system, no. So, as you can guess, we were really, really far from an ideal scenario. What is this SAP security audit log that I keep mentioning? Well, if you go to the SAP webpage by SAP words, the SAP security audit log is a tool designed for auditors to provide a technical detail of what happened in the system. Let me set this very clearly. The SAP audit log is very far from being perfect. It's very far from being perfect, but it's very necessary for you to activate this. How you are going to interact with the security audit log? Well, you have different ways. First of all, in order to activate this, you need to modify a profile parameter. In SAP, every time that you do that, for most of them, you need to restart the SAP system for the changes to take effect. Once you do that, you are ready to start configuring the security audit log with transaction SM19, where you are going to choose all the events that you want to capture. For example, failed login attempts, successful attempts, if a user gets logged, etc. And then from transaction SM20, you are going to be reviewing the logs. When you do a serious forensic analysis, in most cases, you won't be using SM20, and we're going to see later why. And finally, you have the SM18, where it will allow you to delete logs. That sounds sketchy, right? Why I would like to delete those logs? Well, let me tell you that in SAP, there is no automatic archiving right now. So SAP will start logging all the events that are happening until you reach a limit that is configured by this parameter, rsau/max underscore disk space underscore local. And once you hit that limit, SAP will stop logging. You need to do, you can do a cron with a really small shell script to do the archiving of the logs, but you need to do something with those. You need to recycle the logs. It's very important. So at least we got the security audit log, so we have something to start working with. But we have so many events, plus all the logs that were archived, that we couldn't use the SM20. We needed to do something more complex, a little bit more complex. So per each one of the events that we had to, of course, create a parser. We did that in Python. And per each one of the events that we had, we created a structure that I'm going to explain very soon, is the table that you see there. All those events were in a JSON file, and we put that into Splunk because we were using the power of Splunk to later do queries. More or less, per each one of the entries, we state the seed, a word that you are going to hear me saying a lot. The seed is the system identification, the name of the SAP system, the host name, the IP address or host where the event was placed or took effect. Mandant is, you can take it like as a workspace between quotes from when the event happened. The timestamp, very important. The host name of the person that actually triggered the attack. You will get the host name or the IP address depending on the version of the SAP and patch that you are. The username that it was used, the transaction code, the PID of the process, and of course the message directly coming from SAP. So maybe you are realizing right now, wow, Jordan, for each one of the lines that you had in the logs, now you have 16. That is a lot of hard drive. Yes, when you do a forensic analysis, you will need a gigantic hard drive if you want to do something good. So once we added all the events into the Splunk, once we formatted and we added the events, we clearly start seeing common attack patterns. And just then, and because we got the timestamp, the right date and the time where these incidents were happening, we went to transaction SM20 to verify it, to make sure that things actually happen. And what you can see in the image is a very common brute force attack using a default user. That user is very powerful in SAP. That user is like being root on a Unix box. So if you compromise that account, you can do pretty much whatever you want. Let's take a look at the image. First, they try an invalid password, failed logon attempt, failed logon attempt, failed logon attempt, 4 failed logon attempts. But then we see a successful logon. The first thing that we did is to corroborate this with the SAP administrators. Hey, you guys, you were actually using this? This is you? They say no. Okay, so we continue with the investigation. Unfortunately, after someone was able to log into the SAP system using this default and very powerful user, we see that this user uses the transaction SE80. This is bad news because the SE80 is the ABAP development workbench. It's the IDE that the developers use to code ABAP. From there, you can call programs, function calls, you can edit the source code, you can do a lot of damage over there. And we see something that really caught my attention. We see the attacker calling one specific program called rs_testframe_call. This was a really surprise to me. That program will let you mask and completely bypass the security audit log. Before seeing this, I thought I was the only one that had this zero-day technique to bypass the security audit log. But someone else actually found it and used it. This changes everything. Because before, we thought we were dealing with an attacker that were just to Google and say, okay, default SAP accounts, and they try to brute force in their way. But this changes everything. This will require far more skills. So instead of telling you, I'm going to show you. I have 2 live SAP systems on my machine, and I'm going to show you how you will be bypassing the security audit log. Fingers crossed. my machines will behave. So the first thing that I'm going to do, I'm going to start the SAP GUI. This is the client to connect to the SAP system. Going to connect here. Perfect. And we're going to do exactly what the attackers did. We put garbage, failed login attempt, we put garbage, and we're going to log in correctly here. Okay, and then we're going to call transaction SE80 to see this ABAP development workbench on real time. This is the report that the attacker called, rs_testframe_call. This is a default ABAP report that comes from 7.2. It's a very common report. If you click here, you will be executing this report. And this report will allow you to call other function calls. The one that we want to use here is a very well-known function call that will let you read tables. This is just an example. You click here, and you just kindly type the table that you want to read. You do here, and then you click here, and you can see that on this case, we were able to read that table. Let's see what is in the security audit log. Let's see what is in the logs, what we were able to catch, even with the security audit log configured at full expression. So we open a new instance, even with a new user. We go to transaction SM20, that is the one that we could use to review the logs. We click on reread audit log, and we will see something here. We see a failed login attempt, the 2 failed login attempts that we did. We see that we were able to actually authenticate to the SAP system, call the transaction SE80, and we ended up on this report. Whatever happened from that report, we don't know, even if we have all the logs enabled. So that's why I was mentioning at the beginning of the story is that not always the good guy wins when you do an SAP forensics, when you have to do a forensic analysis of such a gigantic type of system. So there is no way to know what the attacker did. And unfortunately, and because of that, let me go back to the presentation. On this scenario, the customer had to assume the worst case scenario. They had to admit that they were fully breached, and they had to notify their customers that probably their credit cards were affected. So, another misconception, another story that I had for you. We thought that SAP cyber attacks were not real. This is a funny one. A Treasury Department of a state of the north part of the American continent receives the visit of a law enforcement agency. And they say, gentlemen, you have been compromised. Your platform is being utilized to distribute malware. But they give us 2 more tips that were very interesting. First of all, they tell the Treasury Department the tip of the spear, the main part of the instruction was your SAP system that you have directly exposed to the internet. In this case, it was a dual stack system. And second, they say that this is a sponsor state attack, but they didn't provide any type of evidence or proof to account for it. They just say it and they leave. So the main concern of the victim here was to identify if personal identifying information was retrieved. Because by law, if that happened, they need to make it public. And they need to go to the Senate to explain what happened. And second, they wanted to understand the intrusion, what really happened, what the attackers were actually doing into the system. So same as before, we asked for the virtual machines, but here, because of the a conference that we had with this customer beforehand, before going to the offices, we already have a theory of what could have happened. But of course, we need the proof. They provide us with the virtual machines, same as before, we mounted this, and we start to see what type of information we actually have. Security audit log, it was not there, nothing, empty. Gateway log, absolutely empty. As it doesn't come by default, there was nothing there. Mesh server log, no, nothing. We only have the Java logs, again, because they come by default, and we were lucky that the Windows events were actually there. So we had to work with that. Again, very far from an ideal scenario, but it's what we got. Of course, we had to create, again, another parser and feed it to Splunk. The good thing about the SAP Forensics is that actually creating a parser for SAP is quite simple. They don't follow a standard log pattern, but it's very easy to create a pattern for it. So I don't know if you can see the screen. Right immediately, we get to see that someone was actually executing operating system commands on the compromised box. That's very clear indication. And then, by looking at the headers, at the logs that we had, we were able to confirm our suspicions by the image that you see at the other side. They were compromised by something that is called the invoker servlet. What is the invoker servlet? Maybe you heard it before. It's basically an application class loader. It will allow you to load classes by their name, on this case, my servlet, or by its fully qualified class name, the whole package in Java, if you're familiar with mypackage.example.myservlet. There is a problem with that. Every single web application that is a servlet in SAP, they come with a web.xml file. And inside the web.xml file, you have what is called the your pattern. That basically, you are going to say, hey, every time someone does jordan.com/myservlet, you need to ask for username and password, and at least the user that is trying to use that server has to be administrator, for example. There is a problem. The your pattern always pointed to the name of the class. So whenever you try to access jordan.com/myservlet, SAP will ask for authentication. But otherwise, if you go to jordan.com/mypackage.example.myservlet, guess what happened? Nothing. You were able to fully use that class, completely bypassing the authentication process. And I got a demo for you, so you can see actually the code that I put it together for you. Here, you can see it. Let me see if you can see something. Basically here, that is the URL that we use. Target 2 is the SAP system that I have running on my machine right now, and that is the URL that we're going to consume to execute operating system commands. Later, if you want to see the code, tell me and I'm going to show you. For example, who am I? That shows that I'm running operating system commands under the privileges of the user that is running the SAP system. From here, I can corrupt the kernel. I can abuse of the trust relationship and jump directly to the database to execute queries. I can shut down the SAP system. I can do whatever I want. You can type whatever you want. So, going back. Our suspicions were correct. We knew that they were compromised by this exploit as soon as they let us know that they have this dual stack system exposed to the internet. This is a 5-year-old exploit. And don't be surprised by the number. I have another surprise for you very shortly. The first thing that we had to do here is to stop everything and tell the customer how to fix this. Why? Because the SAP system was still exposed to the internet. The bug was still there. So after they patched this, and they patched it with what is called an SAP node, kind of like a patch for Microsoft, they had to apply those 3 security nodes that basically will disallow this automatic code execution. The only caveat here is that they had to restart the SAP system. When you apply a patch in SAP, most of the times you had to restart the system. And finally, we were now in the right position to determine, okay, what happened? So we continued working with this plan and were able to get a few takeaways. First of all, yes, they were compromised by a 5-year-old exploit. That definitely didn't look very well. By analyzing the heuristics, there were at least 3 different attackers, 3 different human beings that were executing operating system commands. But the type of the commands, well, I cannot say much. but we didn't find evidence that personal identifying information was actually compromised. The attackers were executing operating system commands, but they never jumped to the database, or they never tried to do lateral movement. That is why you will never hear about this case on the media. It's very common, by the way, that an SAP gets compromised and you don't know it. Another misconception: the probability of an SAP cyber attack is low. Every time that I hear this, I say yes and no. I mean, if you compare it to how likely it is for an attacker to actually attack your databases, your workstations, your phone, so yes, chances are that you're more likely to receive attack in those devices versus an SAP system. There is a problem with this, and let me describe the scenario first. The IT security department, they suspected that they had been compromised. They actually had a compromise a few months ago, and they suspected that the SAPs were actually affected. Perfect. They take this conversation to the SAP basis, the SAP administration, and the security team, and the basis completely disregard this claim. No, the SAP systems were clean, no one actually attacked us. The IT security department actually felt that they didn't have the knowledge nor the tools to prove or discredit this claim. They didn't have the right knowledge, so they called us to do, first of all, a pen test. They wanted to know how easy it was to break into the SAP systems. And then they want us to do a forensic investigation. Hey, we want to really know if someone compromised the SAP systems or not. They want to measure themselves, basically. And of course, they provide a time frame, because otherwise it would be very complicated if we had to analyze the whole existence. They had a SAP system for 12 years. That's a lot of logs, if they had to. So as I was saying, every time someone says, yeah, SAP cyber attacks are not really a thing, the probabilities are really low. Well, they're lower in comparison of other technology, but there is something that happens in SAP that is incredible. Look at the picture that I have out there. What you see there is a vulnerability from 2002. It's a vulnerability in how SAP interacts with Oracle databases. And let me tell you that that exploit right there works like a charm, and 80% of the total security SAP systems that are running out there. It works perfectly, and I will give you total access to the SAP database without even typing the username and password. Let's take a look at why this happens. In Oracle, there is something that is called the OPS dollar authentication mechanism. Oracle has deprecated that authentication mechanism, but SAP still requires it, unless you have like the super and greatest SAP kernel and the super and upper Oracle database version. What does this mean, this OPS authentication mechanism? It means that Oracle believes that someone, somewhere, already authenticated the user. It doesn't care who. The user is already authenticated, I don't care. By default, when you install SAP, you have an operating system user that is called SID ADM. SID, remember, is the name of the system. So if you're dealing with a system that is called PI1, your operating system user will be PI1 ADM. And by default, this user, at installation time, is being configured as this OPS dollar. That user can connect remotely to the Oracle database without providing any type of credentials. There is a trust relationship there, and retrieve one and only one table. That table is called SAP user. In that table, you have a real database user. I know this might sound a little bit confusing, what they will do that. And you will have an encrypted password. That user does have full privileges over the SAP schema. I know this is a little bit confused, so I have prepared this for you. The first thing, all the application servers connect with this really special authentication mechanism to the Oracle database and say, hey, I am the SID ADM. I want to see the content of the SAP user table. So you receive the database user and the encrypted password. The application server will decrypt that password, and it will connect one more time to the Oracle database. Yes, it's weird. Why it will connect again if it was already connected? Well, it will connect again with this SAP SR3 on our sample user, and that user will indeed have full privileges over the SAP schema. Now, let me ask you this. Suppose that we're dealing with a system that is called TL1. Can you create TL1 ADM user at your physical machine? Can you, right now in your laptop, create a user? Yes. So what do you think happens when you connect to the Oracle database? It will let you through without asking any type of username and password. Let me show you. First, I'm going to show you that I have here, I already created a user called TL1 ADM. Let me see if you can see it. Here, right here. And I'm going to use the SQL Plus, the regular Oracle SQL client. Nothing special here. And what we're going to do, we're going to execute that command with SQL Plus. So it's SQL Plus /add target1 is another SAP system that I have running here on this machine. By default, the Oracle port, if it's using SAP, is 1527, not 1521. You can configure this later, but it is this. And then you have to provide the schema, what database you are connecting to. There are 1,000 ways to brute force an Oracle database remotely. Enter. I'm already connected. I never specify a username and password. So here I do select all from SAP user. What I get? I get the real user, SAP SR3, and the encrypted password. Perfect. We reverse engineer the algorithm that produced that password. It was a guess. It wasn't that hard. So we do something like this. SAP SR3, where is the user, and we paste the password. Now we know that the user is SAP SR3 and the password is master TL1. Good. So what do we do next? We just log again, but now we want the full power. So this is SAP SR3 master TL1. There we go. And we can now select all from the table that we saw before. You have full access here. You can go for credit cards, you can go for user hashes, you can pay yourself an extra salary, modify your vacations, you can do whatever you want. You have access, complete unrestricted access to all the information that is on the SAP system. All that without providing any kind of credentials. Okay, so that, of course, was enough proof to show that yeah, it was really easy actually to compromise their SAP system. But let's talk first a little bit more about this remote OS authentication. What is actually there? Well, again, as I told you before, it's an algorithm or it's an authentication mechanism that is deprecated by Oracle. If you go to the documentation for the old version of Oracle's, even there they say, hey, this should never be enabled. This should be in false. But guess what? Again, unless you have the super ultimate version of SAP and Oracle database, SAP requires to have this configuration on. You have to have it on. And actually it's worse if you disable this, because the only way that the application servers will have to connect to the Oracle database is if you have a hard-coded user on the database with SAP SR3 as the name and SAP as a password. So it's even worse. So you can either put a firewall there, or what people do is you configure and you restrict who can actually connect to the listener. There are two parameters once you activate this filtering, and then you specify the IP address or the host names that you want to allow access to the database. There you need to put the IPs or the host names of the application servers, and of course you want to put the IP address of your DBAs. So once we were able to compromise the system, once we were able to prove that it was actually quite easy with a 16-year-old exploit to break into the SAP system, we were in the right position to actually start looking for backdoors. We coded a Java program for that. And in SAP, let me tell you that the code is stored at the database level as well. You have two tables. One is repo source that will contain the source code of the SAP programs. Very important clarification here. People believe that because they cannot read the code in plain text is intrinsically secure. No, the code is there compressed just to save database space, but it's not secure. It's being compressed with the LCH algorithm. And then you have the repo load. Every time that you access an SAP program, SAP will pre-compile it and it will put the bytecode there. So next time you access that program, it will run faster, just that. And we started running this program leveraging the connections that we have from the database, and in no time we were able to actually see what it looks. It was very similar to a backdoor or a proof of intrusion. We were able to determine that it was not directly injected through the database, it was injected through regular SAP means, meaning that someone even edit that from a regular SAP program, SC80, or it was transported. It's how you pass the changes from dev, QA, or production. We saw something like this snip of code. Of course, the URL, I have changed it so I don't give away details of this scenario, but this is more or less what we saw. Someone with wget downloaded an evil script and executing that script. What that script did, it was something very particular. I'm not going to give it away, but literally was a malware, a well-known malware. So let's see how we did this. Let me show you first that we use ODBC to connect to the database, nothing magical here. And we executed our program. I can show you the source code later. It will connect to the database and start finding common attack patterns. And it will give us the output here. We need to adjust the encoding. And of course, this will take you far more time. You will do a couple grabs, but this is the backdoor injected directly to a widely used SAP program. Every time someone triggers this program, this action takes place. So, given what we found there, we were able to determine that indeed the SAP system was compromised in the past. The backdoor might or might not be related to the intrusion that they had before. Because of the missing logs, we couldn't tell 100%. The program again was modified inside the SAP. No one did a direct insert there. We checked it at the database level. We couldn't guarantee that there were no other backdoors. We were analyzing just one SAP system in a very limited set of time. So on these cases, and because of the missing logs, the customer didn't have any other alternative to actually start the planification of SAP forensics over their entire SAP infrastructure to figure it out how that backdoor got there. So wrapping up, what we can expect from these real attack scenarios for these real SAP forensics engagements. First of all, you have to understand that SAP forensics is a quite complicated and really hard discipline. Odds are not in your favor when you do this. More often than not, unfortunately, the customer will not have the logs for you. It's really hard to determine what happened if that happens, if the logs are not there. Expect tons of data sources and entry points. Again, be minded that most of the services out there will have its own set of logs. That's a lot of services. If everything is configured and if you're analyzing all the SAP systems, oh boy, expect terabytes of information. You will definitely need a very powerful hard drive. And it's kind of like two sides of the street. From one side, it's ideal if you have a really gigantic hardware, and from the other side, if you have a solid-state hard drive, that makes a lot of difference. So plan ahead. Extremely important. You can never guarantee that an SAP system was not compromised. If you're telling your customers otherwise, you're lying. You can tell the other way around. You can tell if you find evidence of an incident, but never the other way around. It's very important. And finally, prevent. Avoid yourself to be on this situation to begin with. Patch, very important. It's a big discussion, patching in SAP, I know, but it's very important. Do penetration testing regularly, and above everything, distrust default configurations. They are the source of all evil. Okay, so that was all. Thank you for resisting and for joining me after lunch. If you got questions, I'm more than happy to answer here, or if you see me moving around the room. Thank you.